All right, let's talk about AI. For what feels like forever, the race has been all about one thing: getting bigger, building these colossal, city sized models. But what if a new contender just stepped into the ring, one that proves size really isn't everything? Today, we're diving into a small language model that is making some seriously big waves.
You see, the AI world is absolutely dominated by giants right now. We're talking about large language models, LLMs, with billions or even trillions of parameters. And you can just think of parameters as the little dials and knobs an AI gets to tune while it's learning. And for a while, the strategy has just been to add more and more knobs. But this chase for massive scale, well, it comes at a pretty staggering cost.
So, what if that whole approach is kind of flawed? What if there's a smarter way to build powerful AI? A way that's more efficient, way more accessible, and could completely change who gets to innovate in this field. Well, that's the exact question a new research paper is making all of us ask. Okay, so let's really get into what I'm calling the Goliath problem. The trend, the default setting in AI has been to just keep scaling up. The thinking goes, hey, more parameters plus more data equals a smarter model. Simple, right? But what it's really created is this massive barrier to entry. I mean, just look at the costs. We're talking millions upon millions of dollars just to train one of these things. That makes it a game only a handful of tech giants can even afford to play. It completely sidelines academic research, it locks out smaller companies with great ideas, and running one of these monsters on your phone? Forget about it. It's just not going to happen. That creates this huge gap in who can actually use this technology. And that is where Underdog comes into the picture. So meet MiniCPM. It's a small language model, an SLM, and it comes from a team of researchers at Tsinghua University and ModelBest Inc. And it was built from the ground up to fight back against that bigger is better idea by being insanely powerful for its size. And here it is. This is the big claim that's got everyone talking. MiniCPM, with just 2.4 billion parameters, is showing off skills that are just as good as, and sometimes, believe it or not, better than models like Mistral and Lama II, which have 7 or even 13 billion parameters. It's not just punching above its weight, it's in a totally different league. So, the obvious question is, how? How on earth is that possible? How can a model that's 5 times smaller go toe-to-toe with these giants? Well, the answer isn't about brute force. It's about having a way smarter, way more strategic training plan. This is MiniCPM's secret weapon. The researchers came up with 2 really cool innovations to train this thing. First, there's a technique they call the model wind tunnel, which is all about finding the perfect settings. And second, they've got this unique learning rate scheduler they named warm-up stable decay, but let's just call it the sprint and settle method. It's much catchier. So let's start with the model wind tunnel. Honestly, the name is perfect. Think about it. Before you build a multi-billion-dollar jet, you test hundreds of tiny models in a wind tunnel to figure out the most efficient design, right? Well, that's exactly what these researchers did with AI. They ran tons of experiments on tiny, cheap models to find the absolute best way to train before they scaled it all up. And this right here is basically that wind tunnel in action. Now, don't get lost in the charts. The really important thing to know is that each one of these represents a tiny little model. The researchers are hunting for that sweet spot where the model's error rate or loss drops the fastest. Finding this on a tiny scale lets them map out the most efficient training journey before spending the big bucks on the full-size model. It's just brilliant. Okay, so the second trick is this sprint and settle method. The learning rate is basically how big of a step the AI takes each time it learns something new. Most models start big and then take smaller and smaller steps. But this one does something different. It sprints for most of the training, taking big, confident steps, exploring all the possibilities. Then right at the very end, it settles, rapidly shrinking its steps to lock in the absolute best solution it found. And the result of that settle phase is what's really fascinating. This quote from the paper says it all. During that final quick decay, the model's error rate, the loss, just plummets. It's like a final exam cram session where everything suddenly clicks into place, giving it this massive boost in performance right at the finish line. So, having a clever strategy is one thing, but does it actually, work? Let's get to the good part, the results, and see how this little model stacks up on the leaderboards. Okay, the proof is right here in the pudding. Just look at the scores for coding, that's human eval, and math reasoning, GSM 8K. MiniCPM, our tiny 2.4 billion parameter model, scores a 50 in coding and almost 54 in math. Now look at Lama II 13B, a model that's more than 5 times bigger. It scores a measly 17 and 21. This isn't just a little better, it's an absolute blowout. And it's not just good at tests. This chart shows you conversational skill versus model size. See that little red star way over on the left? Yep, that's our MiniCPM. Now look how high up it is compared to models that are 10, 20, even 30 times its size. It even manages to beat the 70 billion parameter version of Llama 2 Chat. It's just a stunning picture of pure efficiency. Okay, so the benchmarks are amazing, but let's bring this back down to earth. Why does any of this actually matter? Let's get practical and talk about what this could mean for developers, for researchers, and maybe even for you. So we have to ask the big question, right? Is MiniCPM a genuine game changer, a real breakthrough? Or is this just a small step forward with some really great marketing? To figure that out, we've got to look at the whole picture, the good and the not so good. So, who should be paying close attention here? For sure, mobile developers and academics. This tech finally unlocks the real possibility of running powerful AI right on your smartphone. The paper actually shows it running at over 18 tokens a second. That's roughly 13 words per second on an iPhone 15 Pro. For researchers, that wind tunnel idea means they can experiment faster and way cheaper. But okay, there are some trade-offs. The authors talk about an alignment tax. Basically, when they make the model safer and more helpful for conversation, its test scores drop a little. And the biggest unknown? These amazing training tricks work great on small models, but they haven't been tested yet on a truly massive 100 billion parameter beast. The theory is solid, but the final verdict is still out. When you boil it all down, MiniCPM really makes us face a huge question about where all this is headed. Is the future of AI going to live forever in these massive centralized data centers owned by just a few companies? Or is there a future where incredibly powerful AI runs locally, privately, right there in our pockets? MiniCPM is a pretty strong hint that that second future might be a lot closer than any of us thought. This is for entertainment purposes only.